See that okay? Yeah, so basically I thought I would just sort of go over a bit of what my career has been so far, and then sort of my perspective on why I think PhDs are valued in industry, and some advantages of why personally I think you should go into industry rather than academia. So yeah, my photonics career so far, I did a bachelor's in physics at Heriot-Watt. I actually originally joined the physics with teaching course for changing in my second year. I didn't really know what careers were out there, and thought teaching was one of the only physics options really, so that's why I'd stuck with that before realising that wasn't for me and that I most definitely preferred the experimental side of things. So thankfully changed and stayed on. And then after my bachelor's, one of the professors that I actually did my bachelor's project is Ashleigh Barron, and he was in charge of the MSc for photonics and optical electronic devices, which is run by Heriot-Watt and St Andrews. So he was quite an influence for me actually going to do that course. Lasers and photonics was also always the bit that I enjoyed most out of the sort of different experiments and different things that you learn about in an undergrad. So I wanted to pursue that a bit more, and that in-depth master's course really appealed to me, especially because it included a 3-month industrial placement as well, which I took part in Leonardo in Edinburgh in their lasers department, quite similar place to where I currently work. So after that, I went back to Heriot-Watt and completed a PhD, also with Ashleigh Barron and Henry Bucke, who is now at Fraunhofer. He was also sort of supervising me in that project, which was on integrated multi-core fibre devices for optical trapping. That actually wasn't what my topic was meant to be. I spent the first year working also on multi-core fibres, but doped fibres to produce a multicoloured laser. Unfortunately, that project didn't go well. The fibre quality wasn't that great, and we didn't have time to procure more. So we sort of rummaged around in the lab, and my actual topic was born from what we could find, really. And I'll go a bit onto what my PhD was after this. But basically, after that, I wasn't really wanting to go into a postdoc, especially all the ones that were kind of around when I was finishing were short term. But I was offered a postdoc position in a separate group at Heriot-Watt, which it was a short term one. It was only 8 months, and it was industrial funded, and basically everything that needed in this short-term contract, it was all quite suited to what I was doing, of fibres, interferometry, that I kind of couldn't say no. But I'm a bit of a warrior when it comes to sort of finance and things like that. So I kind of was almost straight away still looking for another job when I'd got that, as what can I do afterwards, because 8-month contract scared me like nobody's business. So during that, the opportunity at Thales in Glasgow for a laser engineer came up. It was kind of the sort of role that I was looking for after working in Leonardo for my industrial placement, and those sort of positions don't come up very often, so I needed to apply, and didn't expect that I would get it. It was one of the first proper job interviews I did, but I got it. So it ended up I actually only completed 5 months of the the postdoc position rather than the 8th before I joined Thales. So I basically did all the experimental work and left my supervisor to do the write-up. So I'm hopefully he's still all right with that now. But yeah, so as I said, my PhD was in passive fibres really for optical trapping. It sounds more biophotonicsy, so how did I end up laser engineering? It doesn't sound right. This slide, I've basically summarised my entire PhD thesis just on one page, and with each row being a separate experiment. But yes, it's passive fibres, but there's a lot more that sort of you can delve into what you do rather than the sort of small end result of what your project entails. So I've put some of the diagrams there. It uses a laser, but there is quite a lot of alignment, especially trying to get multiple beams into a small fibre, and then using cameras, using optics, wave plates, beam splitters, all of these things you have to learn about and know how to use them and procure them as well, which is a sort of lot of skills that you accumulate over a PhD or a master's. That you're doing all these things yourself, really. It's not like someone's giving you all this or a ready built up experiment that you just go and do. So there's a lot of skills that you pick up. Like sort of the purpose of a PhD is to become an expert in a really small area, but that's not, to me personally, that's not the most important part of the PhD experience of what you learn through it. It's all those skills that you pick up along the way that you maybe don't realise, but I definitely give you an advantage over if you were coming straight out of a bachelor's course. So it's kind of, I've got a bit of summarising here of why I personally think having a PhD gives you a bit more of a boost going into industry. Sort of like, you have to do all of these things yourself in your PhD. Things do go wrong and they will go wrong, but it's how you deal with them and learn from that and research. You become that sort of expert, but you're doing a lot of looking up, reading, sort of sorting out fact from fiction, which is really important, especially when it comes to working with teams in industry of multiple disciplines. You won't be expected to know every single bit of that, but you do pick up a little bit along the way, which is also what you do in a PhD. Like you're in charge of your entire experiment, so that can be, if you're using something that needs a little bit of a wiring or soldering job or a little circuit, you'll make that yourself. The same as mechanics, how do you hold things in place? You'll design and even sometimes go to the workshop and drill that out. So there's things there that you pick up just through day-to-day life of doing a PhD, along with the sort of presentation skills, going to conferences and speaking in front of people and putting your opinion across as well, really. And also as a bit of a fast learning capability as well. People with PhDs that come into industry, you can generally tend to leave them to get on with it on their own, whereas sometimes the case with people straight out of bachelor's, there's a bit more of a learning curve to get up to integrated into the team. So this is all personally my speaking, it might be completely wrong, but this is what I see as why in having a PhD and going into industry, you are valued above coming straight from bachelor's. It's not like you sort of lose the, why did I spend 4 years doing a PhD or 3.5 years doing a PhD to then go where you could have been before. I don't see it as that. So what have I done since I've been at Thales? So I've worked there for 6 years now as a laser engineer, but I've actually got a couple of different roles under that as well. So when I started, I've basically worked on about 3 products now, and some R&D stuff outside of that as well. But with the sort of first main product was Micromelt, which is a Class 1 LRF laser rangefinder. So when I started that, the design had already been done, and we'd just bought the sort of first prototypes. So I did a lot of the development testing, and sort of saw where it met the spec, where it didn't meet the spec, trying to sort of define our data pack and what that meant, to then go on to the fully sort of first customer qualification builds. And then I was involved in a lot of the qualification of designing the testing and carrying out testing as well. And that unit, that product is now in production. It's going quite well. So, but every now and again I get asked for production support, which is, this is doing something funny, can you come have a look at it? And it's my job to work out why and what fixes we need to do for that. Or is it a laser problem? Is it something else? Get someone else to look at it type thing. Then sort of more recently, I was the lead laser engineer on TLB, which is a Class 3B laser rangefinder. So in terms of the laser engineering side of this, I took that product from the start, of working with suppliers, sorting our data pack. So by that I mean looking at all the optics that we want. They're all custom pretty much, and checking out what do the coating specs mean. Do they do what we want them to do, especially for things like damage threshold, working all that out, making sure we won't have a problem, and sort of defining that, going to suppliers, not all the time that they can make what you ask for. So there's a bit of a back and forth of, do we really need this, or can we live with this? And sort of getting that all sorted. And then through procuring those items in, I was then the one that built the first lasers, and then I worked with production and taught their technicians how to build it. That was actually quite a valuable experience over the last sort of year and a half of doing that. I learned a lot through working with them. Especially I was the one that wrote the build instructions as well. So what I thought might be quite clear wasn't quite clear to someone else. So by that back and forth, I learned a lot and sort of take that forward into future work of how to do that. And of course, in development, you get lots of problems the first time you build things, especially in larger volumes than a couple units that you would normally use in prototypes. So it was my job to find out what was wrong with that and sort it and fix it. And now over the sort of last year, that product, we've completed that order, and now waiting on the next. So maybe like a year or so ago, maybe just over a year ago, I took on the extra role in that product, where I became the lead technical authority. We call it the design authority in Thales, which, because I was I'm not just a laser engineer in that job, really. I was sort of overlooking all the aspects of system. I know a bit of electronics, not I could design a board myself, but I know what the functions are doing and why they're doing it, the same as the software and the firmware and the mechanics of, I know how that all fitting together to make the end result. So I took on that role where basically I oversaw anything, and as that, I'm responsible for basically making sure the product does what it says we do, and with all the qualification things that I did, making sure that is all adequate, and that the evidence I have supports what we're saying, and also safety is a large priority of that, making sure that what we're making is safe and does everything it should do. And yes, now I'm working on the LTDM, which is a target designator. So it's actually the same laser that's inside that's also inside the TLV. It's just now higher rep rate and higher energy. So I'm currently working on that, finding out where its limitations are, what we can do to improve that. These products that we make have to work over a very large temperature range, from -40 to +70 degrees. So sometimes when you build something and it works perfectly at room temperature, when you take it to temperature extremes, you run out of puff or something else happens. So you're a bit like, oh, and have to sort that out. So that's a lot of what I'm doing at the moment. A lot of fault finding, especially a lot of what I learned through the TLV really helped with that as well. Sometimes what you get from production is a sort of end result of what happened, of, oh, this lost energy or something, but really it could be a whole number of things which cause that to happen. So you have to sort of develop a mindset of what does that actually mean, step back and sort of go and look into different regions and of why, rather than jumping straight into something and maybe spending a lot of time or spending a lot of money and trying to fix the wrong thing. So you learn a lot of that along the way. So besides of the laser engineer stuff, I'm also one of the deputy laser safety advisors on site. So for that, I do risk assessments. One of the main things I do is write laser safety papers for the new products. And I also have to look after the eyewear, inspect them, make sure that they're being used safely as well, and that the right goggles are being used for the right products or development tests and whatnot. So what do I think of the benefits of working in industry? Why did I choose coming here rather than staying in academia? Really, a major part of that was actually the job security. I didn't like the idea of short-term contracts in academia, and whereas industry, you don't tend to get that. You get in, and unless something horrific happens, hopefully it's quite hard to get rid of you. I like the sort of impact in real life applications. Now that I've been there for 6 years, I've seen products go from initial development all the way through to being used by customers, and it's quite nice to see that, to know that you're actually working on something that will be used. Whereas my PhD, I mean, it was nice. I got nice papers out of it, nice videos and things, but I don't think anyone will ever touch that again since I left, and not likely to. And career progression as well. So I've had multiple pay rises and sort of gone up some steps in my career since joining, which is possibly a bit quicker than you would in academia. Not impossible, but there's definitely much more steps that you can jump up and increase your wage and whatnot through the way. I get to work on a variety of different projects. So I kind of showed just the products there, but really there's a whole bunch of other things that I've taken part in. Like I've worked on drones and things like that, completely nothing to do with the laser, but just I had a bit of time. So you can kind of see what's going on and get involved in different things, which it's a bit less siloed really than if you're at a uni. And professional registration is something that Thales and other industries really sort of enforce, really, not enforce, but they give money towards getting, like they pay my membership fees, and I'm also chartered with the Institute of Physics, so they've paid that, and they give you mentoring and time to do this all as well, which is quite good. And as also along with the sort of flexible working and other benefits that you get from working for a company as well. Oh, sorry, I've kind of doing. I do have some slides on what Thales is, but I think I've kind of gone quite over my time already. But yes, this was kind of just to say Thales is a big company. If you don't know it, lots of employees and quite a large global presence, and also we spend a lot of money on self-funded R&D. So it's not just working on old things, we work on a lot of new things too. And if you're interested in looking, then for graduate schemes, it's the top link, and direct entry jobs is the bottom one. So yeah, I'll just finish here.
Thank you very much, Ashleigh, for the great talk. So it was really useful to have an insight of what you're doing. And so now it's open for questions. So I have a question. What has been the most interesting project that you've been part of in Thales? If it's okay for you to say it, it's not like confidential.
Yes, no, I think the sort of TLV, which was the class 3B laser rangefinder, that was it was definitely the most difficult, but it's sort of like looking back at it now, the most rewarding as well. A lot of things, because it was one of the ones that I'd seen through from the start, because I've been there a while now, whereas projects take quite a few years to come. And it was definitely what I learnt the most on, and rewarding to actually see it finally working and out being used by customers, and all the little things that we were having issues with a year, 2 years ago fixed. So that's definitely the one that I'd pick.
Sounds good. We also have another question. So what advice would you give to those whose project didn't go to plan as what happened to you?
Yeah.
And we move on.
Yeah, I would just say don't panic. A lot of times experiments don't go right or don't work out, but it's what you learn from them, and how like in academia, probably most of the stuff that you will do won't work out in the end. But what you learn from that is really important as well. Like a negative result's not always negative. And so I was quite lucky in the sense of I came from a really good group, and we looked around and saw what else was there and what else we could do, and it was just sort of by chance that we picked some other fibres up and melted them in a fusion splicer, really, and that's what created my project. But you're not on your own as well when things go wrong, so just don't panic, really.
Okay, so we have a question. How early do you reckon I should apply for a job with Thales with respect to finishing PhD? Similarly to you, I would be worried about being stranded without employment.
Yeah, so personally, I applied in the July, I think it was, and started in October. There's because it's a defence company, there's some sort of security vetting that you have to go through first, which I think takes normally a month or two. So that was kind of my time scale. I think I could have started earlier. That was just what I gave because I was still in the postdoc at the time. But yeah, a month or two is normally what it is between applying and starting.
Okay, thank you. And I guess if you're not a UK citizen, that might take a bit more time to get this done.
Yes, possibly.
Okay, thank you very much.